To everyone, my name is G. Pranit. I am from CSE E section. My complex engineering problem is MAC protocol. MAC protocol means Medium Access Control Protocol are essential to network communication. They control how multiple devices access a shared communication medium. They help avoid data collision that occurs when devices transmit simultaneously. MAC protocols operate at the data link layer of the OSI model. They provide fairness and reliability for communication among network nodes. Applications include Ethernet, Wi-Fi, Bluetooth, and cellular networks. They vary by network type, traffic load, and environmental factors. MAC ensures data integrity in noisy or congested networks. They enable real-time data transmission in mission critical systems. By coordinating access, MAC protocols improve network efficiency. Introduction. MAC protocols are part of an OSI model data link layer. They manage device communication over a shared media. In network without MAC simultaneously transmission causes data collision. MAC ensures orderly access, increasing throughput and reliability. Wireless, wide, and hybrid network use different MAC schemes. MAC protocols must balance efficiency, latency, and fairness. They handle dynamic coordination like node mobility and interference. The role of MAC is critical in real-time and high-density environment. MAC adapts to technology like IoT, 5G, and sensor networks. History of MAC protocol. Aloha was one of the earliest MAC protocol developed in the 1970s. It allowed devices to transmit freely and resend after collision. Aloha had low efficiency due to frequent collisions. CSMA improved this by sensing the channels before sending data. Ethernet adopted CSMA CD, where devices detect and resolve collisions. Wi-Fi introduced CSMA CA to avoid collision in wireless media. Cellular systems use FDMA, TDMA, and CDMA to manage access. TDMA divides time, FDMA divides conqueror, and CDMA use codes. Modern 5G use hybrid and adaptive MAC strategies. 5G and IoT use advanced MAC protocols for scalability and speed. Types of MAC protocols: Random Access Protocol, Control Access Protocol, Channelization Protocols. In Random Access Protocol, device transmit data at will. Collisions are handled after they occur. Examples: Aloha, CSMA CD, CSMA CA. Control Access Protocol. In Control Access Protocol, devices take turns in a managed sequences. Methods are pooling, token passing. Channelization protocols are channel divided by frequency, time, or code. Example: FDMA, TDMA, CDMA. Each type suits specific network architecture and needs. Key features: efficient medium usage ensures no bandwidth is wasted. Collision management improves network reliability. Fairness provides equal opportunity for all devices. Reliability maintains integrity of data during transmission. Scalability supports large growing networks. Low latency is vital for time sensitive applications. Adaptability allows response to traffic changes. Some MACs reduce energy use for battery powered devices. High throughput ensure efficient data transfer. Support for QoS is essential in multimedia applications. Working of Aloha 1 and 1 by 2. Device has data to send and request transmission. Medium is censored for current activity. If idle, device transmit immediately. if busy, device waits or choose a random back of time. Random transmission helps avoid collision. No guarantee the medium remains idle. Potential for collision if other devices transmit. High collision rates reduce throughput. Work well for low loud networks and favor devices. Working of Aloha 2 byte. Data is transmitted to the receiver. If collision occurs, data is corrupted. No acknowledgement is received by sender. Sender retrieves after a random time. In CSMA CD, collision and detect during transmission. Transmission is aborted on collision detection. In CSMA CA, devices avoid collisions using backoff and acknowledgements. Acknowledgement confirms successful receipt of data. Transmission complete only of acknowledgement is received. Random access random access protocol diagram illustrate protocol where devices transmit randomly. Includes Aloha CSMA CD used in Ethernet. CSMA or CD devices sense and detect collision. CSMA CA avoids collision using waiting period. Show backoff and retry mechanism. Explains timing of sensing, transmitting and rechecking. Demonstrate random backoff timer to reduce collision. Highlights differs between wired and wireless schemes. Used in low latency or uncoordinated networks. Control or channelized protocols. Control axis avoids collision via organized access. Polling. Central devices ask each node to transmit. Token passing means token grants transmission rights to nodes. Avoids simultaneously transmission issues. Channelization divides medium by frequency code. FDMA assign different frequency to each other. TDMA divides time into slots for each device. CDMA uses unique codes to transmit to separate transmission. Useful to cellular, satellite and sensor networks. Performance metrics. Throughput. Data successfully transmitted over time. Collision rate. Number of data packets collisions. Latency. Time delay in sending and receiving data. Fairness. Equally accessing opportunity for all devices. Energy efficiency. Power saved important in IoT. Scalability. Ability to handle growing user devices. Responsiveness. Ability to adapt to traffic conditions. Delay jitter. Variation in packet delivery time. Protocol overhead. Control messages and retransmission. Advantages. Efficiency usage of communication media. Better management of bandwidth resources. Reduces packet loss due to collision. Ensure fairness among competing devices. Can adapt to different network topologies. Support real-time and delay-sensitive traffic. Reduces energy consumption in mobile devices. Enables smooth multimedia streaming. Provides support for quality of services. QoS shortcut form. Disadvantages. Random access leads to high collision. Retransmission causes additional delays. Controlled access may cause latency under light load. Complex algorithms are need for fairness. Not all Macs scale well with many devices. Protocol overhead reduces actually data rate. Delay jitter affects real-time communication. Interference and degrade wireless Mac performance. Implementation may be costly in hardware, software. Applications. Wi-Fi uses CSMA or CA to manage access. Ethernet use CSMA or CD for collision detection. 3G, 4G, 5G cellular employ TDMA and FDMA for structured access. Bluetooth uses TDMA for short range wireless network. Use in LANs, MANs and WANs. Ensure seamless communication in enterprises environments. Support streaming, gaming and VoIP. Enable low latency smart home devices. Facilities robust mobile communication. Satellite network use CDMA to share frequency. IoT device use Zigbee LoRaWAN for low power MAC. LoRaWAN use Aloha like protocol for low data rates. Zigbee coordinates access use beacon based MAC. Ensure long battery life for remote sensors. Industrial automation use deterministic MACs. Vehicle use MAC for V2V and V2I communication. MAC plays a role in smart grid energy system. Healthcare devices use MAC for secure data transfer. Comparison with other protocols. MAC versus TCP IP. MAC manages local access. TCP ensures end-to-end delivery. MAC handles physical media. IP handles routing. MAC is 2 layer. IP is layer 3. TCP is layer 4. MAC deals with collision. TCP handles packet losses. MAC is hardware levels. TCP and IP is software level. MAC offers immediate medium access. TCP adds reliability. Used together to build efficient network. Conclusion for this PPT is MAC protocols are essential for effective network operation. They prevent data collision and optimize channel usage. MAC enables fair, scalable, and efficient communication. They are vital and both wide and wireless environment. Modern applications demand low latency and high throughput. MAC supports IoT, 5G, smart grid, and more. Correct MAC selection improves reliability and performance. Future network will need adaptive, intelligent MAC design. They remain a core component of network protocol stakes. Thank you all.